I don't particularly like probability because it gets really um, hard to understand sometimes. So if you start to feel that way with what we're doing now, don't worry, your teacher feels the same way. So we're going to start off. You're given four numbers in those brackets, 2, 5, 7, and 8. We don't want to repeat any of it. So once we use a number, it's gone forever. And you can choose from the remaining groups of numbers. How many combinations of 2, 5, 7, 8 do you think you could make? Or the maximum amount? There's 24. Okay, who's the 24? Zach, how did you do 24? Okay, 4 times 3 times 2. Okay, which is practically, I won't go into factorials yet. Okay, but how we explain this, think of it as branches in a tree. We can have 4 possible starting numbers, either the 2s or the 5s or the 7s and the 8s. But once you've used them, each of those branches has how many options more for the second digit? 3. And once you use 2 numbers, each one of those combinations or ways, in the third spot of the number, they only have 2 choices. The other way to look at it is, this is the long way. We could start off with the number 2. Then that 2 could be followed by 5, 7, or an 8. But if we went 2 and a 5, what would the other 2 options be up here? If 2 and 5 were the first 2 numbers, you would either have 7 or 8. And then if you go again, we won't go even further. If you went to 4, what would the number be up here? It would be 8. What would be down here? It would be the 7. But we're not going that far. And how many sets of these large branches do we have? Okay. Not quite. We can have the 2s. We can have the 5s. We can have the 7s. And we can have the 8s. How many branches does 2 have? 6. Plus another 6 for the 5s. Plus another 6 for the 5s. And another 6, for the 7s. And then the 8s. Giving you a total of 24. The quick way is a 4 times a 3 times a 2. It's 24. Any questions with that first concept? Okay, let's scroll down. I'm going to wipe this off again. Next question. Okay. Determine how many numbers with at least 3 digits that can be formed. At least 3. That means we can have 3-digit numbers, 1, 2, 3, or 4-digit numbers, 1, 2, 3, and 4. We've already answered the first one. The first one was about 3 numbers. But if we go to 4, what are we timesing? If we're counting 4-digit numbers, what's the first multiple? 4. What's the second? 3. And at the very end, what letter, what choice, how many choices have you got on the 4th number? 1's left over. It's different multiplication. but it's going to give you the same number of ways, giving you a total of 48 total ways of having at least 3 digits. Okay, just because the answer is the same from a different question does not mean it's not correct. Okay. All right, next question. You can do your tree diagram, but as you can see, it takes too long. Start multiplying down. Determine how many 4-digit odd numbers can be formed. Think about that. Remember, we've got the numbers 2, 5, 7, and then 8. If I want odds, 12 is correct. How'd you do it, Tim?
Because the numbers 5 plus 7, that means half, which is half. So
That's another way to do it. Good, Tim. You're just using your logical thinking. So there's 2 odd numbers there. You're going to half the total. Okay. The other way to do it is you can 4-digit numbers. In order to get an odd number, how many options in the last digit column are available to get an odd number? 2. There's 2. Okay. But if you've already allocated one number already, how many are available at the beginning? 3. And then you keep going forward. 2. And what goes in here? 1. Giving you 12 in a different way. There's a number of ways you can do this. Just make sure that you use logical thinking as you go. Any questions? Moving on. D. One of the 4-digit numbers is chosen at random. Calculate the probability that it will be an odd number. Okay, we want a probability now. But what's our universe going to be? It's going to be 24. Okay. Because we calculated before to get 4 digits, there are 24 options available. And A being is chosen at random. Okay. So it's a 4-digit being on. If A is this top number here, how many possible events of A or possible events of 4-digit being odd have we calculated? 12. Which gives us a half chance. But if we go back maybe to Tim's logic as before, we know that half the numbers in the set are odd, 5 and 7. But sometimes you can get straight to the answer. Sometimes you might need to do it all the way from the beginning to get that. If you're totally unsure. Let's keep going. Okay. We're going to grab 5 students, put them in a queue. We're going to compare how many ways compared when they're lining up. Now, let me draw a picture. Okay, so they're in a queue. The other way we're going to ask this question is if we ask them to form a circle and how many combinations we have. First question is a queue question. Calculate the number of ways in which the queue can be formed. Okay, as before, how many do we have to begin? 5. 5 options. Each of those 5 options then have 4 options. Each of those combinations then have 3, then 2, and then the last one lines up, giving you a total of 120. The other way to write 5 times 4 times 3 times 2 times 1 is, what's the short way? 5 factorial. Exclamation point, 5 factorial. Okay? But let's see if they gather in a queue. Now, students gathering into a circle formation. Calculate the number of different arrangements in which students can form a circle. Who's got an answer for that? The answer, think of it as in a circle. The answer is going to be 4 factorial. And the only best way I can explain this is in a circle, there's no starting point. There's no set starting point. So you can actually choose wherever you want to start. Whether I'm incorrect in explaining this or not, if you take away the option of the start, you would take away the option of the first one in place. That's disregarded. So it's just a matter of getting into the circle and then doing your combinations. That's how I am sort of explaining it. I don't know if that's mathematically correct, but if you ever get asked circle formations, use this equation here. Our total is 5, and you just simply take 1 away of its factorial, I'm not going to spend too much time on that, and I could be incorrect in my actual theory behind that, but that's one way you could sort of attack that question. Okay, last question. Or maybe second last question. Okay, as you got here, the question is asking 5 students, those 5 eligible for the specialist methods and general maths. So each of these 5 students is doing specialist maths, methods, and general maths at the same time. Who's doing 2 maths at the same time right now? Okay, Hudson, anyone else? Okay. We want to calculate the probability that one person from the group receives the awards. Okay. Once again, let's figure out the moment you hear the word probability, when you're counting, there's two things always that you need to figure out. What's the total ways and the number of ways of your focus group. Okay? In our universe, it's possible each of those people, those 5 students, can win the first one, specialist maths. And each of those, let's best do it this way. Each of those branches or students does have an equal chance of doing the methods. And then each of those people, quite possibly, can get the general maths award as well. 5 times 5 times 5. Giving you a total of 125. Okay? So that's our total number. But what's our number of A? What's the possibility where A is the same student?
5.
It is 5. Getting the award. Getting 3 awards. There's only 5 chances of that happening. Okay, and 5 out of 125 is 1 on 125. Okay, or you can either write it out like that. It's up to you.
That's mostly 25.
25? Yeah, my bad. 25. Yeah, that's right. I think that's right. Okay. It's 1 out of 20. Is there something wrong with that?
The middle ones.
The middle one. This one?
Yeah. Why is it one?
Get rid of the 1 on the bottom.
Sorry?
Because 5 over 125 is an even.
Oh, my bad. Sorry. Just ignore that. Just ignore that. And I'm not going to edit that out. Thank you, guys. That's what you're here for. Okay, last question. Last one for today. There's a bit more, but we'll do it on Friday. Okay, counting with groups with identical objects. For example, these are different examples to what are in the textbook. I just wanted to choose real simple ones to explain the principle. Okay. How many ways can you be bad? Really, I'm saying let's rearrange the BAD as bad. How many different combinations can you get? Who's got an answer straight away? There's 6. Okay.
3 factorial.
3 factorial. Okay. 3 options. Factorial 3 times 2 times 1. Whoops. Equals 6. If you wanted to, you could write them all out. But try not to, because this takes a while. What if it was a really long word? You'd be only doing the one question in the SAC if you did it that way. Okay? Let's change this word now. Instead of bad, let's change it to dad. Okay? We're not saying dads are bad. We just changed the word. Okay? Dad. How many ways can you do it if there are 2 characters in there that are repeating. Who's got an answer for that?
Factorial and 2 factorial.
Excellent, Tim. Okay.
It's 2.
Have you done this before, Tim?
Child love.
Sorry?
Child love.
Okay, good. Good on you. Okay. 3 factorial over 2 factorial. I'm going to explain in a second. Now, if I did dad, if I would still get 6. Dad, DDA, ADD, ADD. There'll be some repeats. That's if I treated this first D and the second D. But really, D is D. So we want to accept any things that we haven't seen, the first 3. And you can notice that these 3 are repeats. That's how one way you could do it, or moisturizing. Okay. 3 factorial over 2 factorial. Oops. The other way. It's really important. This might save you time. Bit of a hack. 3 factorial is the same as 3 times 2 factorial. Are we okay with that? And 2 factorial on the bottom, and the exact same. Keep as many factorial, I can't even say the word, factorials as you can to cancel out. So break a number away to give you your 3 options there. That cuts down time. Okay? Here, you're dividing by the repetitions. Here there's 1 repetition, but it's 2. Does that make sense? There's 1 unique repetition, which is the D's, but there's 2 of them. So I'm going to do one more example where you can see the difference in the concept that we're doing here. Instead of dad, let's look at the word dada. Dada. Think about it. If I want to find how many combinations that I can make with DADDA, what factorial goes on top
5.
is 5. But let's look at the repeats. There's 2 sets of repeats happening. Okay, good. So 4D is a repeat, but there are 3 of them. For A, there's also a repeat. There's 2 of them. Okay? And you can do it that long if you want. And you will get the 3's cancel out, 2's cancel out, 1 obviously cancel out. 20 divided by 2 should be 10. I hope I'm right. Zach's going to test it. Okay. And if Zach proves I'm wrong, I'm going to stop recording here. Okay.